Hello, in this one, I'm going to show you how to take other people's work and make it look like it's your own by using GradCAD. Step number 1, find all the parts that someone else designed and put them into SolidWorks. I'm just going to use the trial version because I don't have money to pay for SolidWorks. Step number 2, take all the parts that someone else designed and put them into a terribly assembled assembly in SolidWorks using very poor constraints to make it look like a part that you designed for yourself, even though everyone else designed the part and all you did was add a few extrusions, cuts, and then pasted them all together. I did it. There's not a chance anyone would ever try and print something this terrible, right? Right? Wrong! It was me the whole time. We're gonna try and print it. Ain't it printed? Let's take a look. Okay, not bad. This actually looks better than I thought it might, I think. Oh no. Dang it. I got a little bit overzealous there and just ripped off the mounts. I think I'm gonna need a little bit better infill, but at least I could probably glue this back together actually. And now I can actually test if this mount's gonna work in my car or not. Up the rest of this here too and see how that's looking. Pretty impressed. I think with a little super glue I can actually get that back on. And what do we got? Camera, GoPro mount, camera mount, Raspberry Pi. This is kind of busted, but it's actually not too bad. I can probably glue this back together like that, kind of. Not too much trouble. Glue faces towards the Ethernet cable, like that. Nice. I think I'm just gonna see how the friction fit feels. All right, it's wiggling around a little bit, but actually not too bad. So we got our setup. Looks like I need to clean off the camera a little bit more. So let's try out a little fire. Honestly, no idea how this is gonna work. Could burn it all, but here we go. Perfect. That's actually way better than I thought it would be. Looks like we're getting a little bit of melting going on, but not too bad. Let's see how it does on this here. Nice. Oh, stinky. I'm sure those fumes are toxic. Awesome. Through. Cha-ching. The Pi camera fits in pretty sweet there. This, which I could super glue, or I may just reprint it with a little bit better properties to make this attachment a little more solid. Let's go out to the car and check how this fits into the GoPro mount. Okay, we're on location with my foreign whip. Got the mount here. Gonna see how this slides into the GoPro mount. By foreign whip, I mean it was made in Japan. Wow, I printed out another one of these not too long ago, and this one fits way, way better. Now for the next part, which is the fun part. I'm gonna go code up basically how this is gonna work. And so what I'm basically thinking is I'm gonna have a battery pack in here with solar panels, and then it'll plug into the car for USB charging as well. When the car's running, it'll be charging through the USB from the car. If the car's off, it'll be charging through the solar panels. Hopefully this large battery pack will stay juiced up all the way. I thought about building one, but I realized that I could buy one for about 40 bucks and it'd be about half the cost of me building one. So I think I'm just gonna stick with that for now. Maybe in the future I'll come back and actually build one out myself, but I think just stick with something simple to get this project moving along. So basically I just need to write code that saves my video. I've been thinking about a couple ways to do this. One of the issues is the Raspberry Pi could lose power, and so I don't want to have like a 24-hour long .mp4 file that just gets suddenly corrupted. So how I save videos at work for one of the projects I work on is I save them into a Pi tables array, and I'm saving them only at like 5 hertz, so 5 frames a second. I think I want a little bit higher frame rate for this, and it's a little bit easier to play back if it's into an MP4 file. So thinking about writing some really simple code that just saves a new file every 15 minutes or maybe 60 minutes. Potentially I can put in a photo sensor. I think I really only want this recording at night, since during the day I'm usually in a pretty safe parking spot, and I already have a regular dash cam for when I'm driving. So really what I want this camera for is just at night to record to see what's going on. Okay, so I'm gonna code this up. I can do a quick walkthrough when I'm done to show you roughly what the program's doing, but here we go. Hey, it's me. Hey, it's me. Hey, it's me. Hey, it's me. It's been a long time since I last talked to you guys, and you can tell because the lighting's different and I'm wearing a different colored shirt. Coding this up took a lot longer than I thought, but I found out some cool new bugs to squash in the future, and let's just take a look at the code and see what I did here. So first up, I import all the libraries that I'm using. Some of these I'm not even using, but there's future things I might want to do with this program, so I just left them in because I don't care that much about runtime. Right here, I sleep for 5 seconds. I do that because when the Raspberry Pi is turned off, it doesn't have a way to keep time. It doesn't have a real-time clock on it. And so if the Raspberry Pi is off for 24 hours and then turns back on, it thinks it's half a millisecond since it last turned off, when in reality it's the next day. Since I'm going to be putting a date and timestamp onto all my video files that I'm creating for the security camera, I don't want that to happen. And so with this sleep timer here, 5 seconds, hopefully the Pi has time to connect to the Wi-Fi at my house before I drive out of the driveway, update its clock to whatever that is, and that way it's more synced up. Worst case, if it doesn't sync, that's okay. It just means that unless the Raspberry Pi connects to Wi-Fi at some point during the day, it's just gonna have no idea of what the actual date and time is. And so it'll make it a little bit harder to go back and find a file from a particular day and time that I wanted to grab data from. Next up, we set up our camera. Here, I specify size of the image that's being saved to the file. Since my camera's mounted upside down, I'm gonna set this vertical flip here to true. If I don't find a camera, I let it know that, and that way I don't keep running a script for no reason. I tried to do some cool stuff with Wi-Fi and figuring out if there's Wi-Fi and waiting, but I couldn't get that to work, so I figured I'd just skip it. I didn't think it mattered too much for this project. Next up, I create a date folder and name it 0. This will be important in a little second, but first I'm going to go through some of the functions that I used. Also, the directory base here is somewhat important, so currently I'm going to be saving to, oh man, I really hope I don't unplug this, a USB stick right here. Save it to that USB drive. I have 3 functions that I'm using for this program. First up, capture video. This records a video inside of the directory that I just named here, names it the current time, hours, minutes, seconds. It records for 60 seconds currently. I think I'm gonna change that to longer when I actually deploy this, probably like 15 minutes. Next up, I have a really simple function that takes in a date string, which is parses it up into sections and returns it as an integer. This function, also used in conjunction with my second function here, takes in an integer that is actually a date number, turns it into a string, unpacks it, and then puts it back into the original format of my date program. You'll see why this is important in a little bit. Use something called sort to figure out which folder is the oldest folder, and then delete that folder if I'm starting to run low on room. Here's the meat of my program, the while loop. This loop is always running, and so everything in here is constantly getting executed unless there's some sort of pause. First up, I list all the folders inside of my USB stick here. Since this is the first day we're recording with this program, there's only 1 folder in here right now. If there's greater than 4 folders, I start to go into this if loop here. Realistically, I think I only need a few days worth of data saved on the Raspberry Pi at all times, and so if I already have 3 days and I start recording into a 4th or a 5th, I don't really care about 4 days ago. I would have already taken the video off if something happened to my car. What this does is it figures out how many folders are in there. We already know it's greater than 4 because it's inside of this if loop. It then puts them into that function that takes a date string and turns it into an actual integer. I then use Python's sorted function to sort the folders numerically. This puts the lowest value folder at the bottom of this list of folders. I then find the lowest folder by just calling the 0 position inside of the list of folders that have been sorted by values. What this line here does is it removes the oldest folder. It's basically just axing that last folder out of existence. I then grab a new date time frame. And so what this does is it takes the date and time from the Raspberry Pi. This is where having the actual time is important, because if this hasn't connected to Wi-Fi and it's been days since the Raspberry Pi run, it's gonna think that it just woke up instance in time from when it last shut down. And so you're gonna start to see days that could be weeks and weeks off of what it actually is if I haven't driven my car in a while. I then unpack that date time into a string of hours, minutes, and seconds, and then create a folder that's years, month, and days. This folder is then compared to the last folder position. So I call this new one 1 and the old one 0. If these are different, and actually I'll back up first. The very first one we know is called 000. So this will always be true when the program first runs. So this will run, it'll create a new 0 with folder, it'll make a new directory, path, with the base being inside my USB stick and then the name of that folder being the current year, month, and day. It'll try and make that new directory. If it already exists, like if I turn my car on and off in the same day, then it's just gonna realize that there's an error, basically do nothing. Lastly, I just actually capture the video. And so what this does is it captures video, runs our capture video function. So right now it's just recording 60 seconds of data. Let's say it just recorded 60 seconds, goes back up to the top of my while loop, checks the numbers of folders. So maybe if midnight just struck, there's an extra folder, has to delete. If not, this isn't true. So it's gonna skip that and grab a new date time, save a new date time. If it's still the same day, then this also is gonna get run. So essentially, what this is doing every loop is really just checking the number of folders and capturing video, unless it's been a new day or I have a lot of days that have been saved. Just to prove to you that this is actually working, I'm just gonna go inside here of my record, and this has actually been running the whole time that we've been sitting here talking. And so this one might not open because it's still being worked on. Okay, awesome. So you can see me there yammering away at you, pointing, and yeah, pretty cool, honestly. So to wrap this up, I'm just going to change a couple values, and I think we're ready to put this in the car. I'm going to record for 15 minutes. Wow, I was way off. I'm probably just going to cut that out. This program is running at the startup. I'm using cron tab E, and to do that, you just do sudo cron tab E, and then down here at the bottom, I call up the virtual environment that I'm using. I say where the file is located, run it, and then I'm also saving an error logger so it's easier to debug things that go wrong. And I'll put all the source code in the comments if you're interested in checking it out. I'm powering this with this solar powered battery pack, pretty sweet, and I'm just plugging it straight into the Pi. And so all that's left to do, I think, is super glue this onto here and then slide it into the car, and we're good to go. I was actually pretty sure I didn't have any super glue, so I'm very stoked on this find. And so you can see here, this is where my print delaminated from itself. I definitely should have just made the infill a little bit thicker, and this probably wouldn't have happened, but since I already printed it out, I'm just gonna try and throw a little super glue on there and see if that does the job rather than having to reprint the entire part. I think that's gonna work. I don't want to yank on it too hard, but I think that's going. I think it's gonna take a bite. So just set this here, and yeah, I think we're ready to go out to the car. Sadly, since the super glue didn't work out, at least I don't think it's gonna be a good long-term solution. I decided to reprint the entire thing. I don't have any real modifications except for the infill, so I feel kind of bad reprinting this, but it's whatever. And this way I get to check out my new Octopi server that I just set up. So first, I'm going to show you how I set up the project in Cura, and then we can check out Octoprint real quick. So one other thing I was thinking about when I was going to bed last night was maybe I should be printing this in this orientation. That way my axis of weakness, where the layers are, isn't directly aligned with my hinges, right? Or my most likely point of failure right here. So I think I'm going to try and print it upright. I know it's going to take longer just because it's going to be a lot more layers, but it'll be a little bit less rafting, and I think it'll make an overall much stronger part. So let's give that a shot. So first up, I definitely want to up this infill. I'm probably going to go 60%. Since most of these features are pretty thin, that's actually not going to increase my filament amount by too much, and it should really make these weak points much, much stronger. The only thing I'm slightly worried about is the bendability of these arms here with the higher infill density, but hopefully it's nothing too bad. Okay, so somehow this turned out even more janky than I thought it could be possible. There was still some wet glue on the bottom, so I put a little toilet paper on the bottom, and yeah, the time lapse actually had the sunset on it. You'll see that in a sec, so that was fun. But the print itself actually turned out pretty good, so that I am pretty stoked about. So these do not like to be printed that direction. Dang, do I have to print this diagonally to make it work? Clear all this crap out and take a lighter to it. Yeah, I mean, that's so thin. It's gotta be printed like that for those pieces to work. But I mean, sadly, that just makes this also a very weak point. So maybe if I put some sort of angled joint on this, that would help out with that. I think I'd still be facing like a lot of the same separation issues. I just got to increase the surface area of contact here. And actually looking at this, I think I could probably widen that up a little bit. And if I increase the infill, printing it along this axis would probably work out actually. So there may be something to try. I'm on my final go around for this because, I mean, yeah, that's not what you want to see. Just gonna rip the toilet paper off of this. Try turning this on right now. Should see the cameras light up once the program's actually running here. Maybe question if my 5-second wait is good or good enough. Oh, we're going. Heck yeah, that's awesome. And so, okay, I'm gonna let this record for 15 minutes and then pull this stick out, check it on my big computer, and see if I have a file for today's date, which is May 1st. Let's go, May 1st. Should be like 2 or 3 files. Perfect. Oh my goodness. These 3 lines here took so much longer than I thought they ever could. Basically what this does is it creates a command. I'm have to use a command because Python doesn't actually have a built-in process to convert MP4 from H.264 files. And so the thing that I'm using is actually happening inside of the Linux command prompts, but I can call it within Python by using the commands process. So it's a subprocess.call, and my command is mp4 box -add, and these quotation marks is what killed me. I looked at a bunch of different tutorials online, and I just couldn't figure out like how to get the quotations marks with my save path. We got it working now, so I convert my H.264 files, which is what the Raspberry Pi camera natively saves. I convert that to the MP4 and then delete the H.264 file. And so now it's much easier to read on my computer, and I don't have to convert it when I'm trying to put it into a video or anything like that. So, okay, time to take this Raspberry Pi outside. Grab a battery bank that we're gonna use to power it in the future, and grab the Pi, which has the mount, and we're good to go. Okay, this outside, it's a little precarious. I've definitely had less precarious things before, but it's whatever. And we made it outside. I'm definitely gonna need a better way to secure this whole battery pack setup. But yeah, first off, I'm just really stoked to see how this camera mount, or this GoPro mount, works out, even with a couple of chunks missing. Yeah, that feels pretty good. Honestly, that back peg, like, I mean, okay, so I just ripped this out. I don't even think I really need that because there's not a lot of sliding sliding back and forth forces. And so, I mean, this is in here pretty dang solid, which I'm pretty stoked on. I'll just like have this sitting up here and have this plugged in. And so some sort of like piece of Velcro that attaches onto this. Well, the car's off security camera solution. Is this low angle actually good or not with the Raspberry Pi camera? Like, what am I seeing out of this? One option it would be to tilt this back a little bit so it's looking up a little bit more, sliding the entire GoPro mount back towards this direction, or making this stand itself taller so it's a little bit higher up. Something to hold this ribbon cable down and maybe just enclose the Pi in general would look a lot more clean for sure. But I think I'm just gonna let this run today and see how it looks. So there it is, my Dashcam implementation. I really wanted to do this just because it's a project I've been wanting to do since I was in college, and I never really had the time to get around to it. I'm really stoked, and I hope there's some application for you that you could possibly use part of my code or my general idea of making this dash cam. I just recently bought a dash cam from a major manufacturer of GPS products, and it was kind of expensive. It was 150 bucks. The only cost there is the Raspberry Pi. I could have probably used the Raspberry Pi 2, or even possibly a 0 with a different ribbon cable going to the camera. The camera is like 10 bucks. It's the same exact accomplishment of what my name brand dash cam does. The camera quality may be a little bit lower, but you could get a better camera that's native to the Raspberry Pi for just a little bit more money, and it's still half the cost. I mean, I think my current setup was like 45 bucks. If you got a better camera, it'd maybe be 60 bucks, but I paid 150 for something from a name brand manufacturer, and that's just a lot more for really the same functionality and just a few hours work of tinkering around.